Michael Franz will talk about verifying everything every time.
So of course, you notice that the initials of the talk. So what I want to talk about is sort of maybe a little further away. Actually, I came here thinking that I would hear lots of wacky talks on very exotic things like Python and so on. And I think now in retrospect, maybe all those things were less wacky than what I'm going to speak about. So we've had all these interesting vulnerabilities that I'm sure you're aware of. During the course of this little workshop, we heard something about a new exploit affecting JPEG files. So these things keep happening all the time. And the interesting thing about this, of course, is that all hopes that we could completely automate the defense against this, by having some kind of a virus detection or so, fairly futile if we have a whole attack that happens in something like 10 minutes. So no human can react in time to actually stop anything like this. And so right now, how we're doing this is having a patching regime. And the interesting thing, of course, about patching is that if Microsoft can't patch its own servers with something that they know exists for 6 months, and Microsoft itself gets affected by something like the slammer worm, then the patching solution definitely isn't very good. The interesting thing is that so we're building all these nice little virtual machines with verification like Java, and we're building them on top of operating systems that are completely unsafe. So it's very nice to have a very safe little Java virtual machine sitting on top of a very unsafe operating system. And the other thing that's interesting is that, and this is good if you want to get money from military people, if you want to frighten them, to say, how many of those bugs that we see are actually real bugs, and how many of them might actually be intentional backdoors that are put there by evil agents of certain foreign states who happen to work for Microsoft. And I mean, it's actually, if you think about how much it would cost to infiltrate Microsoft, it's far more cost effective than building a single missile. And so this is probably something that foreign intelligence services are doing if they're worth their money.
Economics says it would.
It makes complete economic sense. So So I asked Bill Gates this question about a month ago at the Microsoft Faculty Summit, and I said, how many Chinese agents work in Microsoft? Bill Gates sort of looked puzzled, and then he replied something like, if that would be our greatest problem, I would be very happy, because really, Microsoft doesn't really care. As far as they're concerned, an error is an error is an error. But it doesn't really matter whether it's an intentional error put in by a foreign agent.
Well, an even more economical way would be to just, get a hacker to find an error that, a security flaw externally. I mean, why inject one when there's a lot you can find?
Well, but it might make sense. But I mean, if you know about an error and nobody else knows about it, that's a definite strategic advantage.
You can do it either way. Yeah.
Now, but so the interesting thing is that sort of almost unintentionally, some of these products have become essential facilities, and actually, government in I would claim our whole economy actually depends on the correct functioning of some of these things. And so an error that someone else knows about might actually be far more dangerous. And I think the most interesting error that actually recently was detected was this thing in the Cisco router, where someone might have been able to remotely shut down the backbone of the US internet simply by sending a certain packet sequence across it. And someone could have done that in the case of a conflict remotely from outside of the country. And so this is something that is actually quite interesting and dangerous. And so security is important. And so my claim is that actually this community could be, solving some of this problem in part, because we could actually apply all these nice results we've had over the last few years to make things safer in general. And the idea there is not to talk just about mobile code or these little virtual machines that sit somewhere, at the very top and run a few applications, but actually, why don't you just now take the next step and say, okay, in the good old days, we had the safe code platform sitting on top of an operating system somewhere, and you had to trust all these things. And obviously, the operating system now is huge, and the safe code platform is also starting to be huge, but it's not as huge. The interesting thing is, until about 15 years ago, operating systems were these tiny little things, and compilers were these huge things. And now it's pretty much the other way around. So why not just invert this whole thing and try to build some kind of a safe code platform that you can actually put an operating system on top of? And I believe that we can actually now do that. And we should try to be doing that, because then we could do, and the idea here is, don't even trust the boot block of your hard drive. When you turn on the machine, something that's embedded with the processor, sealed in a tamper-proof package, starts to run, and it contains some kind of a verifier, and all the code you ever execute on your machine is going to be verified prior to execution. So even if your janitor is some foreign agent who manages to do some evil things to your machine while you're away, it's going to be verified, it's going to be detected at the time you turn on the machine. And I think if we had such a thing, we would actually be able to not just sell it to the feds, but also to banks, any kind of large corporation that does some sensitive things. So what we actually need, and of course I'm a compiler guy, so if you have a hammer, everything you see is a nail. So this is a great compiler problem we have here. So I see this kind of an architecture where we actually have, something that operating systems have anyway, hardware abstraction layers, except that you now need to have some kind of a higher level typing system in there. And we have one compiler down here, which does dynamic translation on the level that supports the operating system. And then we have another virtual machine, which is the same kind of Java .NET virtual machine that you already have, except that this virtual machine now is itself completely expressed in terms of the lower level mobile code format. And on top of that, somewhere you have the application code. Now, so the first thing is, I'm sorry, Java won't cut it. I mean, you won't be able to put a complete operating system on top of Java unless, Cliff got an honorable mention. And the other problem is that we now need to be able to verify everything, and the verification thing, unfortunately, is also not completely for free. Very few people here actually talked about verification. So it's very nice to be doing virtual machines, but the verification thing is kind of a nasty thing. And in the case of Java, for example, you actually have a verifier that is sort of in practice linear in most cases, but in theory actually has quadratic complexity. And so this is sort of almost a little sideline, but you could actually use the verification cost itself as a denial of service attack. And we did a little experiment here. We actually built a tool that creates valid Java bytecode files that have worst case verification complexity. Okay, so just in case, it's quadratic. Some implementations are so poor that they actually are more like much worse than quadratic. And so I don't know if you know what the verifier does. So basically, it does a data flow analysis, and then when you have a back edge, you obviously have to go and make sure that the types that you have inferred down there match the ones up there. And it basically just iterates until it reaches the steady state. So you can actually construct a data flow that just, on every back edge you introduce something new, so you have to loop around again. So, I mean, those of you who actually know Java, can look at this. Everyone else just look away. So here I'm actually, the box ones are the ones that we know have just changed from the previous iteration. And then whenever you see a branch in the Java verifier, you actually take it. So here we have a branch, so we go down here. We know this is an integer. This a means some pointer. And then, as you can see, this actually ripples up, and you need 5 iterations to verify this little program, just to show, in the end, of course, it's going to say, yes, it does verify. It is a legal Java program. But the activity of finding out that it is a legal Java program is very costly.
Mike,
Now,
have you looked at the split verifier of the micro edition?
Yes, I'll mention it later. Yeah, so the split verifier actually uses some kind of what you would call type proof carry code. Basically, the type maps are the fixed points of the data flow iteration. The problem, of course, is that Java itself right now is, predicated on the original verifier. So
Is this a consequence of the verifier or the problem? I mean, this looks like constant propagation to me. A year.
it's a consequence of the problem, but the problem is that the verifier itself requires that you be able to process this kind of stuff.
But you could do a different algorithm.